Today's lesson is on square root functions. At the end of this lesson, you should be able to graph a radical function, state the domain and range of the radical function. Square roots are the natural inverses of squaring. In other words, to find the square root of an input, we must find a number that when squared gives us the input. Because of their important role in higher level mathematics, it is important to understand their graphs, as well as their domains and ranges. In this lesson, we will explore all of these facets of the common function. So consider the two functions, f of x equals the square root of x, and g of x equals the square root of x plus 3 minus 2. Graph y equals f of x without the use of your calculator on the grid shown, label its equation. So go ahead, pause the video, and find the y values and graph it. You should know that the square root of 0 is 0, so this graph starts at the origin, and then I filled in the table of the three values given. So now in part B, using your calculate to generate a table of values, graph y equals g of x on the same grid and label its equation. Start your table at x equals -10 to see certain x values not in the domain of this function. So go ahead and grab your calculator, plug in the g of x function, and get the table. Should look something like this. So now we can see at -10, it's imaginary. If your calculator is in a different mode, it might say error. So on our table, we're going to write E for error for -10, -9, -8, -7, -6, -5, -4, and look at -3, we finally have a value of -2. And then -2 is -1, -1 is a decimal, 0 is a decimal, 1 is 0, and all the way to 6 is 1. So, pause the video and please graph this g of x function. So you can see on this graph that I have the f of x function in blue and the g of x function in green. Now remember, we've talked about this before, the transformations that took place. This transformation means that I went left 3, and this transformation means I went down 2. And if we look at the points, left 3, down 2, left 3, down 2. Each of the points on this parent function, remember this is called the parent function, has been moved left 3 and down 2. Okay? That obviously impacts the domain and the range. So in part C, we need to state the domain and the range in set builder notation of the original and g of x. So the domain of the original, domain is left to right, so the domain starts at 0, and it goes to positive infinity. But this says set builder notation, so we're going to say x such that 0 is less than or equal to x. We could have also said x is greater than or equal to 0, and that's our set builder notation. Our range is bottom to top. So the bottom of this graph, the lowest point in the graph is 0, and the top is positive infinity. So we're going to say y such that y is greater than or equal to 0. So now, how does translating it, moving it left 3 and down 2, impact the domain and the range? Well, the domain left and right, now we start at -3, so x such that x is greater than or equal to -3, and our domain, or our range, the bottom of it is now at -2, So y such that y is greater than or equal to negative 2. And hopefully you can see that by the graph. Remember, domain is left to right, range is bottom to top. Right? And when there's arrows, that means you probably have infinities in there somewhere. All right, next question. As we saw in the first exercise, the domains of the square root functions are oftentimes limited due to the fact that square roots of negative numbers do not exist in the real number system. Very, very important. So please highlight that. Okay, remember, when we talked about domain and range, it was of the real number system. Okay, so that's why we couldn't have those imaginaries. So, which of the following values of x does not lie in the domain of the function y equals square root of x minus 5. So go ahead and grab your calculator and graph that. And look at the table. So it says x equals 6. So when we look at x equals 6, we see that the y value is 1. When we look at x equals 2, we have a problem. It's imaginary or an error. When x equals 5, we have 0, and that's a value. And when x equals 7, we have 1.141421 ... which is irrational. So we could also have those values. So the answer that does not lie in the domain is the number 2, choice 2. Now in this question, we have to explain why. So let's look at this. It's a square root. This answer has to be real. So this answer under the radical has to be greater than 0. And when you graphed this, we saw that it was from 5 above. So to solve these kinds of questions and find the domain, you take what's under the radical, the radicand, and you set it greater than or equal to 0, and you solve. So we're going to add 5 to both sides. So x must be greater than or equal to 5. Well, 5 is greater than or equal to 5, so is 6, and so is 7. That is why my answer to number 2, choice 2, is not the answer. Well, we have to explain that. Because x equals 2 makes the radical less than 0, which is not part of the real number system. Okay? All right, pause the video, take a minute to read the box about finding the domain of a radical function, and then we're going to practice a bunch. So the first one says y equals square root of x plus 2. So set the expression inside the radical greater than or equal to 0. So x plus 2 is greater than or equal to 0. Therefore, subtract 2 and subtract 2. X is greater than or equal to negative 2. Now, that was nice because that was linear. It's going to get much, much more difficult when we have quadratics, when we have coefficients in front of x. Those will give us fractions most of the time. So like example, the original example, like exercise 2 and this same one, we got some nice whole numbers for answers, which show up obviously in our graph when we graph it. That doesn't always happen. So algebraically needs to be part of your plan or your knowledge. So we're going to take 3x minus 2 and make it greater than or equal to 0. Add 2. So 3x is greater than or equal to 2. Divide by 3. X is greater than or equal to 2/3. So again, remember, this is the domain, and it asks us to write them in set builder notation. So x such that x is greater than or equal to negative 2. X such that x is greater than or equal to 2/3. And the last one, again, set it greater than or equal to 0. I'm going to add the 2x over, so that it's not negative, because I don't want to have to deal with switching the inequality sign. So 8 is greater than or equal to x, divide by 2, 4 is greater than or equal to x. So x such that x is less than or equal to 4. So those are my domains. All right, why don't you look at the next exercise and graph it, and then continue the video. So this is what you should have had for part A. Now for part B, it says set up and solve a quadratic inequality that yields that domain. So we're going to solve that algebraically. So set up and solve that yields the domain. So x squared plus 4x minus 12 is greater than or equal to 0. Well, to solve it algebraically, remember, when it's a quadratic, we make that quadratic into an equation. Therefore, we're going to say what multiplies to 12, negative 12, and adds to positive 4. This is an easier of the quadratics because there's no number in front of x squared. So we have x and x. You should have said 6 and 2, a positive 6 and a negative 2. So therefore our answers, when we set them equal to 0, x equals negative 6 and x equals 2. And again, this is a quadratic, so we take our critical points and we put them on the number line. Because it's equal to, we know they are shaded in, included. We're going to pick 3 values, one in each section of the number line, to test. So I'm going to test negative 7, I'm going to test 0, and I'm going to test 4. What I should find out is that this is true, this is false, and this is true. So this is shaded and this is shaded. So my answer, my domain for f of x is x such that x is less than or equal to negative 6, or x is greater than or equal to 2. And I could see that by graphing. X is greater than or equal to 2, or x is less than or equal to negative 6. So some of these you will have the shortcut of being able to graph them and find the solution. And sometimes you will have to solve them algebraically because the graph is not easy to read. It's not conclusive. They're not whole numbers for your answers or whatever. Good luck with this. If you have any questions, ask in class.